This is Math Studies Section 1.2, Factors and Multiples. So our first definition is factor. A factor is a natural number that evenly divides a number. So, for example, let's talk about the number 20. Uh, 20 is divisible by 1, 2, 4, 5, 10, and 20. Those are the factors of 20. A multiple is a product of a number with a natural number. So let's talk about 20 again. The multiples of 20 would be 20, 40, 60, 80, and so on. Multiples would keep going. So this is 20 times 1, 20 times 2, 20 times 3, 20 times 4, the products that we would generate by going up the natural number set. The greatest common factor would be the largest factor that two numbers have in common, and the least common multiple would be the smallest multiple that two numbers have in common. I'll do examples of those below, so I won't do them here. The first example says list the factors. So I have 18 things that can divide 18. I can divide it by 1, by 2, by 3, and the easiest way to do these, if you're not really good at getting them, is to just go up the number set and test every number. Does it divide by 1? And you get a whole number and it does. Does it divide by 2? And it does. Does it divide by 3? And it does. I would test 4 next. If you do 18 divided by 4, you'll get 4.5. That's a decimal. It's not a factor. So skip 4. 5 won't work. 6 will work though. And then we have 9 and 18. So 3 and 6 make 18, 2 and 9, and 1 and 18. Those are the factors of 18. I'm going to list these out. There are a lot though, so I'm going to kind of write them. 1 and 144 will make 144. And then I'll try 2. 144 divided by 2, that's 72. So that works. We'll try 3. 144 divided by 3, that's 48. So 3 and 48. 144 divided by 4, that's 36. So 4 and 36. So we can just keep going up the natural number set, and as you notice, we'll get those pairs and they come down. So once we've reached the bottom of this number set and the top of this number set, we'll have all of them. I know without even trying 5 on my calculator that it won't work because all multiples of 5 end in either 0 or 5. So I'll try 6, and that worked. 6 was 24. I will try 7. Don't think it'll work, but just in case. That one gave me a decimal, so I'm not going to use 7. 144 over 8 gave me 18. 9 gives me 16. And you can see I'm getting close, so I know there can't be many more. 10 won't work because it has to end in a 0. 11, I know that won't work, but 144 and 12, I know 12 times 12 is 144, and that means I have all of my factors of 144. Letter B says list the first 6 multiples. So the first 6 multiples of 2 would be 2, 4, 6, 8, 10, and 12. The first 6 multiples of 5, 5, 10, 15, 20, 25, and 30. So again, just 2 times 1, 2 times 2, 2 times 3, and so on. 5 times 1, 5 times 2, 5 times 3, and so on. Okay, we have prime factorization. Now I'm going to draw this the way that I learned it. If I want to take the number 60 and split it into primes, I want to start dividing by the lowest prime number, which is 2. So 60 divides by 2 and leaves me with 30. I'll divide by 2 again. 30 divides by 2 and leaves me with 15. I'm going to try to divide by 2 again, but that won't work. 15 is odd. I cannot divide by 2. So I'm going to try the next smallest odd, or next smallest prime, which is 3. 15 does divide by 3, and it leaves me with 5. And I know 5 is a prime number, so I have found the prime factorization of 60. I have a 2, a 2, a 3, and a 5. So I'll write that 2 squared for the 2 2's times 3 times 5. So this method we branch down. It's very organized. I like it, but it kind of takes up a lot of space, especially with these larger numbers. So rather than branch this one down, I'm going to branch it down and out at the same time. I'm going to put my prime down here. 84 divided by 2 leaves me with 42. And then I'm going to branch out my prime again. 2 and 21. 21 is odd, so I cannot factor out a 2, but I can factor out a 3, which leaves me with 7. 7 is prime, so I have my prime factorization. 2 times 2 times 3 times 7. I'll write that 2 squared for my 2 2's times 3 times 7. I have 2 more examples. The first is find the greatest common factor of 63 and 84. There are a couple methods to do this. You can use the prime factorizations, but I'm going to show you a different method that just has you list out the factors and then you look for the largest one. So we're going to start with 63. Factors of 63 would be 1 and 63. Not 2 because it's odd. 3 and 21. Not 4, not 5. Not 6, not 7. Wait. 7. 7 and 9. Not 8, so I reached the bottom end because I hit the 9. Those are all my factors. And we can rewrite these closer. It's kind of up to you. I'm going to leave them how it is. Now we have to do 84. 1 and 84. 2 and 42. Did we... I think we did 84 above. Yeah, we did it up here. Oh, that was for prime factorization. Never mind. Okay, 3 and 28. 4 and 21. And I can stop there because I've noticed that I hit a 21 here, and that's my second highest one. I don't have a 63, and I have a 21. I could keep going to get the rest of the factors, but I don't need to now that I have found the greatest common factor. Both of these sets, their highest number is 21. So 21 is my answer. Last example, letter E, says find the least common multiple of 15 and 18. So we'll start by listing multiples of 15, and I'll just kind of go up a ways till I feel like I have enough. Okay, now I'm going to list some multiples of 18. And I know my 15s, but I don't know my 18s. So I'm just going to start on my calculator with 18 and keep adding 18 to it. And then again, we want to go until we see the same number. And luckily I stopped there, and that is my answer. 90 is the lowest number that both of these number sets share. Okay, so we have our examples and our notes finished. That leaves you to the exercises. Good luck with those.